Now we will see the Bohr's model of hydrogen atom. Model of hydrogen atom. Previously, Rutherford's theory proved the nucleus charge is positive, and he said protons are placed inside the nucleus and the dimensions of the nucleus also he found. Before him, one small concept of electron was discovered by J.J. Thomson, but there are some failures and limitations are there. So there are some limitations and failures, and Mr. Rutherford, he couldn't predict what is actually happening. So because of that, one more theorem was developed to modify the Rutherford's postulates. That was given by Mr. Niels Bohr, and his model is said to be Bohr's model of hydrogen atom. So what are the limitations of Rutherford? Why the concept of Bohr's model was erased? We will see now. Actually, in the Rutherford's model, nucleus contains positive charge. So electrons are stable around the nucleus, and this structure is similar to the solar system. These are all the views and expressions of the Rutherford about his atomic structure model. Solar system. In solar system, gravitational force is the key to hold the solar system stable. Where the sun is at the center, all the planets are revolving around the sun in their own orbits or one of their focus. In solar system, gravitational force is the reason to hold or to stabilize the solar system. But which forces are the reason to stabilize the atomic structure? The concept is going like this. Positive charge and negative charge, automatically there is a Coulombic force of attraction between these two charges when they are separated by a distance. But if electron is revolving around the nucleus in their own orbits like this, in circular orbits, if the electron is revolving, it will get a centripetal acceleration. Because centripetal force is the reason to to keep the electron in the limits of the orbit. If there is no such a force, electron will come out of the path. We know that. So centripetal force or centripetal acceleration plays a key role to keep the electron in the limits of the orbit. But we know that any orbit, any object or any electron which is revolving in a path continuously, it will radiate energy. Means this electron, while it is revolving continuously around the nucleus, there will be a loss of energy for this electron. Whenever there is a loss of energy, this electron will take the spiral path like this and completely merge with the nucleus, and this causes to destruction of atom. Complete destruction. That means if this is proved, if this prediction is right, then what we can understand, no atomic structure, there is no single atomic structure which is stable. All should destruct because of the spiral path of the electron towards the nucleus, because of the loss of energy while they are revolving around the nucleus. So one more thing, whenever these electrons in the spiral path, when they are approaching the nucleus, there is a possibility for the change in angular velocity, angular frequency, This means these two will change, because in spiral path this electron is approaching the nucleus. This is very, very important. When it is approaching the nucleus, its energy will increase and its angular velocity will increase because it is under the influence of positive charge. Its angular frequency will increase. Therefore, frequency of the radiation emitted by the electron will increase or will change. Frequency of radiation. This also changes. So these three are related to each other. Automatically these three will change. That means this electron which is revolving in the spiral path should give a continuous spectrum. Means continuous spectrum. What is the meaning of continuous spectrum? The order of the wavelength should be continued. There should be no gap. But what type of spectrum we actually got, or Mr. Niels Bohr observed? Line spectrum. By gathering all the information, he came to conclusion that classical theories or classical electromagnetic theories are not sufficient to explain the concept of atomic structure. That's why Mr. Niels Bohr in 1912, after visiting the Rutherford's laboratory frequently, he added some more points. On those points, he took from classical quantum theory, which was newly developed at those times. So he adopted some points to his own atomic structure, nothing but the Bohr's model of hydrogen atom, and those points he added to his own theory. Those are said to be Bohr's postulates. See, if one theorem is failed, one postulate is failed, there is an alternative. So like that, J.J. Thomson failed in some aspect. Next, Rutherford proposed some theories based on his alpha scattering experiment, and Rutherford is not able to explain all these things what we have discussed now. That's why Bohr assumed some predictions by taking the inspiration of the quantum theory. Now, what are those postulates and how they are valid, and what are the limitations, and what are the explanations of the other scientists to the Bohr's model, we are going to see. Now we are going to see the Bohr's postulates. Bohr's postulates. There are three important postulates according to the Bohr's model. We will see one by one and its explanation. First one. In Rutherford's model, electrons are revolving around the nucleus, right? Such like that. What is the Bohr's first postulate with respect to the motion of electrons? Electrons will revolve around the nucleus, and each electron will exist in a specified states around the nucleus, and each of that specified state has their own energy. That is the first postulate. And one more thing, the second postulate is like this. Electrons are revolving around the nucleus, right? So the electrons will revolve around nucleus in their own orbits, and the angular momentum of those orbits should be quantized, and that quantization factor is h by 2 pi. Third one, electron may take transition from one energy level to the non-radiant another energy level. In this case, the electron may emit the photon. The energy of the photon which is emitted is equal to energy difference between initial and final states. The postulates are states like this. Electron exists around the nucleus in a particular stable states. These are called stable states of atom also. These stable states have their own energy. Each stable state has their own energy. This is the simplified form of the first postulate. What is the second postulate? Electron will revolve around the nucleus in the orbits or steady states where the energy of where the angular momentum of those orbits should be quantized. That means electrons will revolve or we can write revolves because it is continuous, right? Revolves around the nucleus in orbits for which the angular momentum is quantized and the quantization factor is h by 2 pi. Angular momentum is quantized and quantization factor is nh by 2 pi, where n is equal to 1, 2, 3, so on. This h by 2 pi is the quantization factor, where n refers to the state, means energy state, first energy state, second energy state, such like that. And third postulate, electron can excite or de-excite, can jump from one atomic energy level to the another non-radiant energy state. In this case, they will emit a photon and the energy of the photon is equal to difference between the final and initial energy states. So it is like this. Electrons transition takes place from one energy level to the another non-radiant energy level. So in this transition, photon may be released. In this transition, photons will be released. And the energy of this photon, which is released due to the transition of electrons from one energy state to the another energy state, is equal to the energy difference between initial and final states. So the frequency of photon emitted is equal to h nu is equal to EF minus EI, where h is equal to Planck's constant, nu is equal to frequency, EF final energy of the final energy state, EI energy of the initial energy state. These three are the postulates of the Bohr's atomic model. Now we are going to see the equation part. With this Bohr's postulates, we can find out the velocity of the nth electron in an orbit, radius of the orbit, energy of the orbit. These are all set with Bohr's orbit, Bohr's radius. Now we are going to find out that.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.